explain the digital multimeter. This is also a clamp-on ammeter, so I can measure voltage, resistance, and amps with this one meter. Got my test leads. I have a common port that I put the neutral or 0 volts in, and then the voltage on the red. When I first pick up my meter, I want to make sure it's a category 3 or 4, which it is. That's good up to 600 volts. I'm going to turn it on to ohms, and then I'm going to touch the leads together. You can hear the beeping. I'm going to wiggle the wires where these tend to break. Everything's good. So this is a good meter and good test leads. If I was to store this, I'm going to make sure it's off. I've also put a screen protector on here to prevent any scratches so I can always read this accurately. I'm going to put it in my soft case. I'm going to store this in a cool, dry place. If it's in my work truck or vehicle, I'll put it down on the floorboards by the seating and leave the windows cracked a little bit. Try and avoid any stepping on or heavy or sharp objects or any water. Okay, first thing I'm going to do is measure voltage, alternating current voltage. So I'm going to put my test leads in. Again, the black goes to the common. The red goes to the voltage. Turn it on to ohms. And touch the leads together. And you can hear it's responding. It has a continuity circuit. Place that down. I'm going to turn it to AC voltage, which is the wavy sign. The other one is a flat line or signal line. That's for batteries and solar panels. That's DC, direct current. So I'm going to put in my leads with voltage AC. That's showing 114 volts. I can press hold, and I have that measurement if I want to hold it, and I'm going to take out my leads. The safety point I want to make is if you put one lead in, the other lead has the same voltage, so it's hot, so don't touch it or touch anybody else with it. Pull them out at the same time. It's the safest way to do it. Now I'm going to turn it back off and reset it and go to amps. And I have a light plugged in behind me, and I'm going to use the clamp-on meter, which uses a magnetic field. These wires are split, the hot and the neutral, with this little device. I'm going to clamp it. It's going to show 3.9 or almost 4 amps. If I need an accurate reading, I'm going to go to the 10 times, which means it has 10 coils of wire in there, and it'll read 10 times as much amps. And that's showing 41 amps or 4.1 amps if you divide by 10. The proper way to check a current for a bigger cable is open up the clamp and put it in the middle, not near the corner or pinched. These have little steel laminations to pick up magnetic field, so you don't want to leave that open. You get an inaccurate reading. If it goes in the corner, it's inaccurate. It has to be right in the middle to get the proper magnetic field to make a good reading. Now to check a fuse, you can check a fuse in 2 ways. You can go to the ohm meter check, again touch the leads, and that'll be a continuity of circuit. Take a fuse, and you can put one lead on one side and one lead on the other. That's telling me the fuse is good. Some fuses will break down with amps or volts, so the most accurate way to check if a fuse is good is with the voltage on it and current running through it. So you'll go to AC voltage if it's for AC. You'll put the common on a neutral or grounding bus, and you'll touch both sides of the fuse and look at the volt reading. If the volts are the same, then the fuse is good. If the volts are off by 1 volt or more, the fuse is probably not good under load.